Right, so I'm Kelly Murphy. I'm the founder and CTO. Welcome, everyone. I'm going to first talk about software-defined storage to put that in context around what we're doing, and most importantly, talk about the value that that can actually deliver. We'll have a second session after this where we then start to go deeper into how we actually deliver that and how the technology actually works behind this. Just following from what George had put up here, this is probably the most important point when you actually look at the problems that people have with virtualization, is that when they virtualize applications, they run slower. Okay? They end up spending a lot more money because of storage. It's almost like there was an evil plan from storage vendors to come up with virtualization so that more and more storage would actually get consumed and utilized. And storage vendors have actually done quite well out of this over the last number of years because of the number one problem, which is performance is bad. So that's the second thing. And the third is the complexity. And I want to talk about the architecture. And again, not boring you guys because I know you can do this with the back of your hand, but it's just to make a couple of obvious points on this. If you think about what virtualization did, and everybody talks about that, virtualization has really changed the data center. It's forever changed in the way it works now. The way it's done that is in two steps. The first is that it virtualized hardware. So it created a pool of resources out of servers. Okay? And on top of that, it created a new container. That container is a VM. And that VM is now kind of free to float around on top of this virtualized pool of resource. The more that, as that container needs resource, it's, delivered up from the hypervisor. Now, the real, clever step that virtualization is that it was completely transparent, right? If it wasn't transparent to the applications, to the operating systems, to the hardware below it, none of this would have worked, right? It would never have got adoption. So because it's completely transparent, there's no change to the OS. The OS doesn't know anything that's changed. The application doesn't know anything's changed. The hardware is the same. But now when you look at the context of the application, everything around it has changed. Okay, so that traditional storage architecture, which if that was just a server with an application running on top of it, you'd optimize that in a nice one-to-one, relationship. Now you've got this kind of many-to-one relationship, and it's impossible to optimize for that. Okay? You've got, the I/O blender that everybody's talked about for a long time. Nobody's really solved that, and it's because of this one-to-many problem. You've got one LUN effectively carrying sometimes 10, 20, 30, maybe even 100 virtual machines. Okay? So trying to optimize for that is practically impossible. The result is you get, these really random performance drops. You're running nice and clean all of a sudden. That application, that was truly optimized, the operating system is producing nice, clean, optimized I/O, but it's all blending together. And it depends on what else is happening in that environment. All of a sudden, the performance drops. Nothing's changed, but the performance dropped, okay, because somebody else is busy in the environment. Somebody else is consuming resource, and there's contention all of a sudden. So it becomes very unpredictable. Is the first thing. The second is there's no visibility. Right? When all that I/O disappears into that kind of funnel, there's no way to start to fix these problems. So that's the second issue. The management also becomes a major issue for people because you have, as I said, 10, 20, maybe 30, or even, depending on if it's desktops, it could be hundreds of VMs, all sitting on that single LUN. Now when you want to do a snapshot and replicate that, if it's array-based, okay, which is where all the data services traditionally sat, now you're snapshotting for 100 VMs and replicating that somewhere. So now all of a sudden these data services start to really bloat, okay? All that, is adding cost and complexity to this environment. And this is the crux of the problem. And really what it is this misalignment between the storage architecture that was there for practically 25 years before virtualization came along and this new kind of virtualized architecture on top of it, okay? And because virtualization didn't change anything above and below it, that's where this misalignment is actually coming from. So when we talk about software-defined storage, we're really putting in the context of how does it solve this problem in a virtualized environment, okay? This isn't about putting, open source software onto other people's hardware. This isn't about just maybe moving the management layer and saying I can control other people's hardware. It's really about how do I align storage, the storage architecture with virtualization. So the first thing is creating this pool of resource. If you follow what happened in virtualization, what we're doing is effectively mirroring that same set of steps. The first is that you take hardware and you pool it together, okay? We use a grid architecture behind this so that we can get, this kind of scaling and so on. But what you have is this single resource pool that you can start with and you can grow. And you can grow different types of resources in that as you grow. The second is you create a new container on top of this, okay? That container is a virtual controller, a virtual storage stack. And that virtual stack is now mapped one-to-one with each of these VMs, okay? So what we've effectively done is gone back to the original architecture where you have a single application running on a server with a storage subsystem that can now be optimized on a one-to-one set of relationships, okay? Fundamentally different from what was there before. The third thing that's happening right now is if you look at the data services and management of this, everything is moving to the hypervisor. So things like snapshot, replication, and so on do not work on a LUN-based architecture anymore, right? They just bloat the data services. They're too granular. They're too expensive. They're too cumbersome, okay? People want to work on a per VM basis, okay? So the third thing that is happening, and this is not just about Gridstore and our approach to this, but it's more about a trend, in the marketplace, is these services are moving to the hypervisor. There's no stopping that. VMware is doing it. Microsoft is doing it. More and more of these services have to move to the hypervisor. People really want that kind of management efficiency. They want it to be simple. They want it to be easy to diagnose problems when they have problems. They want to be able to see and isolate those problems. The golden rule of scaling is isolation, right? When you mix everything together, it all falls apart. If you look at kind of web scale companies and so on, that's the golden rule. You create isolation, you create zones. If you don't do that, you can't scale. And that's what people are looking for. So software-defined storage is really about bringing those three things together. And George kind of went through the intro, and I'll talk more about our architecture and the product and how we deliver this, but there are really three capabilities that we bring that were not possible before. This idea of being able to optimize on a per VM basis from end to end, okay? Being able to have a storage quality of service that works from the VM all the way through to the disk, okay? And having a real simple and efficient way to scale that storage, and scale it in different types of resources as well, okay? So we'll come back to that. This is, from our perspective, what software-defined storage really has to deliver. It has to fix the performance problem. Everybody complains about it. It has to drive down costs. We believe you can cut the cost of storage by as much as 75%. When you eliminate all the replication, all the bloated data services, all the over-provisioning, it's a ton of storage. That's why the storage industry is happy right now. And you can make it much, much more simple. Okay? And that's a key thing for helping people to scale and scale efficiently. The last point I want to make on this is it is a very disruptive change to the storage industry. If you look at what's happening here, in terms of the architecture, it's completely reversed. Right? This is not something trivial. If you started here, to get over to that model is not simple. Okay? You do literally have to reverse the storage architecture, and it becomes completely distributed. The second is that if you think about where most storage companies actually make their money, it's in the data services. Okay? You're now looking at all of that function capability moving somewhere else, moving into somebody else's bucket to collect revenue from, mostly into the hypervisors. And the third thing is that, that resource pool is being built on x86 hardware, commodity hardware. So this is a very disruptive change to the storage industry. It's literally yanking out the core where they make their money. It's commoditizing the storage and the hardware behind it. And it's reversing the architecture in a way that makes it very difficult for them to get there.
Kelly, there's a, VMware has been moving down this path for quite a while, but they have I'll call it a upper limit for what kind of things that they will do from a vSAN perspective or some of the other things, data services wide, which leaves an opening for all the storage vendors, quite frankly, to continue to provide those services on a more enterprise scale, highly available, resilient, that sort of thing. I see to some extent Microsoft's doing the same thing with Hyper-V. I mean, there are limitations to what sort of things you can put into storage spaces and or their counterparts of vSAN and stuff like that.
Right. One of the limitations is with both the vendors is that they have to work with a lot of existing storage vendors. Yeah. Okay, so what you see them doing is adding layers and layers of APIs and complexity on top of that traditional storage stack. So they're, and one of the stories that George told me, when he was talking with the CEO of VMware was, one of their biggest challenges was storage, because that is what's restricting the growth of virtualization because of the cost of it, because of the complexity. So they're looking for ways to solve that problem. Absolutely, they have to. If they want to grow their business, they need to solve that problem as well. But the reality is that, they're, as I said at the start, they're trying to change as little as possible in the actual infrastructure stack because they have to work with everybody. And so, they're coming up with layers and layers of these kind of APIs that are trying to fix or mask some of these problems, but really they're adding more complexity on top of complexity. Okay, so we've taken a clean sheet of paper and said, how would you do this today?
Okay. I'm a mite confused because you install as a mini port driver. So it's a block level device.
Yeah.
So how do you get the context to do per VM QoS?
Yeah. I'm going to go into that in the next section.
If you were file level, I'd understand. Okay.
So we have some little black boxes that are sitting in there that are...
magic.
Yeah.
That's what it is. I forgot about the unicorn tiers.
Yes. And that's an essential part. You're absolutely right. Because you need to be able to find a way to detect where that I/O actually came from.
Yeah.
So we have algorithms that run in there to do that. And that's sitting in that driver, and that's what it's actually doing. It's isolating, detecting, and isolating where that I/O is coming from. And then we tag that I/O, where it came from, and we move that across the network. We put quality of service on that, and we move it across the network.